Hi, I am going to now explain how GPS proves satellites and put an end to this one aspect of flat Earth nonsense once and for all. I see this discussion comes up a lot in flat Earth forums and discussions, and a lot of flat Earthers make the claim that it's a ground positioning system. Unfortunately, most of the people arguing against them take the argument on the wrong level. They ask questions such as, how does GPS work in the ocean if that's true? And they continue along that line. So this misses the actual essential mathematics here. What I'm going to do is roll this back to a more detailed level. We're going to forget about phones and GPS devices. We're getting down to the basics now. And what I'm going to show is how GPS signals finding your location prove the satellites completely, conclusively, incontrovertibly. There's no way to argue against this. If you think you have an argument against it, please present it in detail, show the mathematics. You'll be world famous for overturning all of math and physics. More power to you, but you can't just say, nah. I'm going to show in detail, and if you want to say that something's not true, you have to show in equal detail back. Now, I'm going to do this really simple since most flat earthers can't think in 3D. I'm going to present everything in 2 dimensions and make it really, really simple. I'm going to oversimplify, but I'm not missing anything important here. And in 3D, it works exactly the same way. I'm just simplifying it to 2-dimensional ideas to help with flat earthers because they can't think in 3D. So let's say you know the location of a building and how far you are from that building. So for example, I know where this building is. I know I'm 5 kilometers from the building. Then I know I have to be on this circle around the building that's 5 kilometers in radius. Super simple mathematics, right? All of the points around that building there are those places that are 5 kilometers from that building. So if I know where the building is, I know how far I am, I must be on that circle. Now let's say I can confirm my location by some other means, like, hey, I'm at my house. I know where my house is. Cool. And I really am at my house. Then I know that information is correct. I know the location of that building, the distance I have, where I think the building is, and how far I think from it are correct if I'm on that circle, or I have good reason to believe it's correct. We'll get to that in a second. So first question is, what happens if the building is actually somewhere else? What if my information is bad? Well, if the building's somewhere else, let's say I think the building's over there, that blurry image, but the distance is correct in this case, then the information I have tells me I should be in that circle. But I'm not on the circle because I know where I am. So my information is bad. I know immediately that the information is wrong. The building location or the distance must be wrong. However, let's say you're trying to be sneaky, like flat earthers like to lie and make up little weird situations. So sure, let's say the building was in this spot instead, and I'm still in the circle. So it's telling me the wrong information, and I'm still in the circle. Oh no, right? No, wrong. There are a few places where the circles will match up here. However, it's really simple. I just have to move, right? I'm still in the circle. I think the information is good. All I have to do is walk around. Super simple. If I walk around a little bit, suddenly the information will no longer be good, right? Unless I walk on this exact line between the 2 buildings in this one particular example I'm giving. If I walk around a little randomly, or better yet, have a friend walking somewhere else with me, we'll see very easily and very fast that it won't match up. So here's where I think the building is, and as I get closer to the actual building, then the distance shrinks and the circle moves away from me, so I'm no longer on the circle. I see immediately the information is bad. So you can't use these weird contrived examples because it has to hold up if I walk around as well, not just for this one example where I'm sitting still. So what happens if the distances are wrong? Well, the same principle applies here for the same reason. If the distances are wrong, you won't be in the circle for obvious reasons, right? The circle will be too small or too big. Well, what if both the distance and the location is wrong in such a way that you happen to be on the circle again, right? It could be farther away. It's pretending to be farther away, but the circle is pretending to be bigger, and then you're still in the circle. Fine, move around, and you'll see again, right? All these weird cases where the wrong information happens to be right, for that one exact location, all you have to do is move and it won't hold up anymore. It's impossible, completely impossible for the wrong information to be consistent. And here's the key fact. The building does not know anything about you. This signal, this information is just out there in the air, the distance. And we're going to get to exactly how that information is found soon. But it's nothing to do with you personally. The building doesn't know where you are. So it cannot give you specialized wrong information that adapts to your location. It has no idea about you. So what happens if we have 3 buildings instead of 1 building? Well, this is way better because if they give you the right information, those 3 circles will meet at 1 point and 1 point only, exactly where I am. So this is perfect. If the 3 circles meet at 1 point, and that's where I am, I know all the information is super correct. It has to be. That's the only way the 3 circles are going to meet exactly where I am, if the distances and the locations of those buildings are correct. And then I can know where I am really exactly. Before, I only knew I was on the circle somewhere. Now I have an exact location for myself. So we're at the intersection of the circles. Great, my information is correct. And this is the only spot where all 3 circles meet. So this is where I have to be if my information is correct. And once again, if the distances or locations are wrong, it's not going to match my observation. So here, if the distance is wrong, but in this case, it's even easier. It's not only that it's not matching my location, the circles won't even intersect at 1 point. So it's even easier to see when it's wrong. It's not just that I'm not on the circle or I'm not where they meet. The circles don't even meet at 1 point. If the location is wrong, the same thing. The circles don't meet at 1 point anymore. And once again, if you happen to have some weird contrived example where all 3 locations are wrong and all 3 distances are wrong and it happens to intersect by just the way they're all wrong in exactly the right way, that will only work for that one spot. As soon as you move, it won't work. Try it, you'll see. Easy to show, super easy. So nothing holds up if you walk around, and better yet, if you have a friend getting the same information and you're both walking around, the only way that it'll correctly tell both of your locations, is if the information of the distance and the location are exactly right all the time. The only way. This is the only way. Simple, simple, simple math. So then we have the question is, how do we actually get this information? How do we know the location and distance of these buildings? Well, imagine the buildings are constantly sending out a radio signal with only 2 pieces of information. Where the building is, or where it says it is, and the time. So it says, for example, right now it's 3 o'clock and I'm at this location. Right now it's 3 o'clock and 1 second and I'm at this location. Just broadcasting these signals out. Not targeted at any particular person, not targeted at a device. These signals are being broadcast in the air where anyone, including you, can build a device and listen to these signals. Anyone can listen. And the only thing they're saying constantly is, here I am, this is my location, and this is the time. Nothing else. Okay, well, who cares about the time? How does the time help? Well, the time gives me the distance because I see the time I receive the signal, I see the time it says it sends the signal, and then using the speed of light, I can calculate the distance. What if the speed of light is wrong? Or what if they're lying about the time? Oh my God, what do we do? Oh no, I never thought of that. Well, this will just give me the wrong distance, right? If I'm using the wrong speed of light, or they're giving me the wrong time, then that's the same thing as saying the distance is wrong. And I already showed you that if the distance is wrong, the calculations won't work, and it won't give me the correct location, the circles won't intersect. So it's immediately a check on the speed of light, it's immediately a check that the time is right, it's immediately a check that the location is right. If any of these are wrong, it will not tell me where I am. It's not possible for it to consistently tell me my location. This is the key part. This is important. It is completely impossible to come up with any type of signal from these buildings that has the wrong information that will consistently give me my location correctly as I move around. This is not possible. This is the core of the argument. If you think this is not true, if you think otherwise, show it in detail. Show me the type of signal that will always work and give me my location correctly as I move around, where it's not having the correct information on its location and time, or any one of them. Show me how that's possible. Remember, the buildings have no information about me at all. They're just broadcasting this signal. Anyone can listen to it. Anyone can receive this information. So it can't be anything based on where I am, where I'm going. This has to be generally broadcast information that anyone can listen to, that somehow, when I do the calculation based on the location and distance it's giving me, will always give me my exact location. Show me how that works. If you can't do it, you have to admit that this completely proves satellites. The only argument you can come with now is, nah. What does this have to do with GPS? Guess what? This is how GPS works. This is how the satellites work. Forget your cell phone. Forget GPS devices. The argument isn't about that. Throw them all away. It has nothing to do with that. Anyone, including you, can build a receiver and listen to the GPS signals. These satellites are broadcasting this information. They are just over and over again broadcasting, this is the time, this is where I am. This is the time, this is where I am. You can build your own receiver, bypass your cell phone so no one can track you, or whatever crazy thing you believe in, and listen to the signals. They're not aimed at anyone, they're not aimed at a phone, they're not aimed at anything. Anyone can listen to them. You'll hear signals from somewhere, just repeating location and time. You don't have to believe they're satellites to start with, but when you use them and calculate your location and see that they calculate your location personally and exactly, and they're correct all the time, then you know for sure that the time and location they are giving you has to be correct. And the location they're giving you, of course, is in space. Guess what? You've just proven, or I've just proven completely, that space exists and satellites are in space. And that, oh, by the way, for those of you who have the weird thing about the speed light, that also has to be true. If any of those are not true, it cannot give you your location. If the location that they're telling you is wrong, the time is wrong, the speed of light is wrong, then when you calculate the location, it will be wrong. But it gives you the location, you'll do the math, and it'll tell you your location exactly. You can move around, confirm your location, calculate again. It will always be exactly correct. The only way it will be correct is if the location and times, and by the way, the speed of light, are all correct. If your location is correct, the information must be correct, the satellites exist, thus GPS proves satellites. End of story. It's the only way you can calculate position accurately just from the information transmitted. This cannot be faked. It cannot be faked. It is not possible. If you think otherwise, prove it. Get away from the nah. Show in detail how this information can be fake and still allow you to calculate your exact position. It should be easy if you are right. Prove it or shut up with your flat earth nonsense. Thank you.